Hello students, welcome to JRF with Ria. In this video we are going to discuss about the altimetric analysis, average slope, relative reliefs, dissection index and law of channel slope. These are the relief aspects of a drainage basin. The first is altimetric analysis. Altimetry includes the numerical frequency of highlands including summits of floods at various altitude, for example slope heights, summits, shoulders, benches, etc., which are believed to preserve old erosion surfaces, and hence altimetric analysis helps in identifying and determining erosion surfaces. The next is average slope. Slopes defined as angular inclination of terrain between hilltops and valley bottoms, resulting from the combination of many causative factors like geological structure, absolute and relative reliefs, climate, vegetation cover, drainage texture and frequency, dissection index, etc. are significant morphometric attributes in the study of landforms of a drainage basin. Using following formula as suggested by Wentworth, tan value are derived and actual slope angle resulting from tan values are obtained from the log table. So, slope angle is equal to tan theta is equal to n into I by 3361. This is for FPS system and 636.6 for the metric system, where n is equal to number of contour crossing per mile or per kilometer length and I is equal to contour interval. The slope categories: first is level slope. The slope varies between 0 degree to 2 degree. The gentle slope, this is from 2 degree to 5 degree, moderate slope from 5 degree to 15 degree, steep slope from 15 degree to 30 degree and very steep slope above 30 degree. The next is relative relief. Relative relief, also termed as aptitude of available relief or local relief, is defined as the difference in height between the highest and the lowest points in a unit area. It may be grid square. Relative relief is an important morphometric variable which is used for the overall assessment of morphological characteristics of terrain and degree of dissection. M.A. Melton in 1957 suggested to calculate relative relief by dividing the difference of height between the highest and lowest points in the basin with basin perimeter. Thus, relative relief is equal to H by P. Relative relief is classified into 6 categories. Extreme low relief, this is 0 meter to 15 meter. Moderate low relative relief, 15 meter to 13 meter. Low relative relief, 13 meter to 60 meter. Moderate relative relief, 60 to 120 meter. Moderately high relative relief, 120 meter to 240 meter. And high relative relief is above 240 meter. Next, the dissection index. Dissection index, experiencing a ratio of the maximum relative relief to the maximum absolute relief, is an important morphometric indicator of the nature and magnitude of dissection of terrain. Solicitors use real area and projected area between successive contour to calculate dissection index between different height group as follows. Di is equal to Ra minus Pa divided by Pa into 100, where Ra is equal to real area between two successive contours. Pa is equal to projected area between two same contours. D. E. Smith in 1951 suggested modification in the above scheme by including volume of relief and average slope as follows. There Di is equal to Ra minus Pa into average slope divided by volume. The volume of dissection index derived for each grid of 1 square kilometer dimension are classified into 5 categories. Extremely low dissection index, that is 0 to 0.1. Low dissection index is equal to 0.1 to 0.2. Moderate dissection index is equal to 0.2 to 0.3. And high dissection index is equal to 0.3 to 0.4 and very high is equal to above 0.4. Next is law of channel slope. The mean channel slope or gradient is defined as the ratio of vertical drop of horizontal dissection measured from the upper end to the lower end of a single stream segment of a given order. The law of channel slope, as propounded by R. E. Horton and applied by M. Marisova in 1959 and Leopold and Miller in 1956, states that mean channel slope decreases with increasing successive orders in geometric series with constant slope ratio. The next is slope profile angle. Profiles drawn from the contour map are of great assistance to the geomorphologists who are primarily concerned with the analysis of relief and surface of terrain, because profiles provide a visual perception of the actual nature of terrain. But the profiles drawn from the contour map must be verified through field check. Generally, profiles are basically of two types: river profiles and terrain profiles. River profiles are further divided into longitudinal and transverse profile, while terrain profile are classified into serial profile, superimposed profile, projected profile, and composite profiles. So that's all for this session. Thank you for watching. Keep watching and keep learning.